Rochwerger from Radware. Radware is a company based out of Israel. We specialize on application delivery control and security. And I'm here going to talk about the experiences that we had developing this anti-DOS application on top of OpenDaylight and the trade-offs that we made and how the environment was very friendly for us to develop in. So before I go into actually the integration on OpenDaylight, let me explain you a little bit about what our application does. Essentially, the Defense4All is the open source version of our SDN-based anti-DOS. Essentially, it's a system that detects DDoS attacks and has the mechanisms to take traffic that is an attack traffic and move it somewhere else to be cleaned up. So the target of that attack never feels that it's under attack. And we do this purely using SDN-based elements, both for the detection and for the diversion. So basically, how does this work? What we see here is all the components of the application. We have our SDN controller, obviously OpenDaylight. On top of that, we have our anti-DOS application. This application communicates it's not integrated in the controller itself. It communicates with the controller through the controller REST APIs, to the northbound API of the controller. Clearly, we have our user interface. And at the bottom, we see our network. Our network is made out of physical machines. It's made out of virtual machines. And we have something called a scrubbing center. That is the place where the attack traffic is cleaned up. Now, to do this is done on hardware devices. It can be our device, or it can be somebody else's device. The application itself knows how to divert the traffic to the scrubbing center, and the scrubbing center does not necessarily have to be based on our devices, because all the application is doing is moving the traffic there. There are some optimizations that we do, and I'll show you what it means. But essentially, it will work with any anti-DOS device here. So how does the system work? We have this concept of protected object. The user, through the UI of the system, defines a set of machines or a machine or a link that it wants protected. So as you can see here, out of many machines, I have set up protection for this particular physical machine, and I have also set protection for this set of virtual machines. Now, what this means is that our system works with whatever the components that we're trying to defend. We're not really, or should not be, dependent on whether this is virtual, this is physical, on what virtual technology you're using. This is all theory, but this is the main idea. Once we have defined our protected objects, the user gets out of the picture, and the system takes the definition of protected objects and translates that into counters. We essentially go to several places in the network, and we put specialized counters that count different types of traffic. This is not just counting bulk packets, but we do have counters for that count TCP traffic, and we have counters that count ICMP, and we have traffic counters that count UDP, and the detection is actually based on the relations between all these different traffics and the behavior of this traffic, of these different types of traffic over time. and of the location, because it's different if we're having a counter at the entrance of the network or we're having it at the very edge of the network. We expect different behaviors. So what we do in the applications is we take the results of these counters. Once we have the counters, we periodically poll. This is a polling system. This is, as I mentioned, it's a REST API. So we need to poll to collect the information through the controller from the different counters. Then we actually put together all the different counters and we learn for any specific protected object what is the normal behavior, because different machines have different normal behaviors. So it's not like you can say, well, this particular traffic pattern means that you're under attack, because for some it may be okay, for some others it may not. So essentially, we collect over time, we learn what is the normal traffic of a particular protected object, and then we look for anomalies. We look for anomalies that mean that based solely on counters, we do not analyze the data. It's based solely on counters, on insights that we have on the behavior of traffic, and what does these counters mean, that we actually say that we have suspicious traffic. It may not be an attack, it's suspicious. Yes, you had a question?
Why not inspect the flow data right there?
What?
I said, why not inspect the flow data right there instead of just counting the high-level stats?
Because if we were to move all the traffic through the controller to our application to actually do the analysis, neither the controller nor the application will be able to. The idea here is to just, with very little information, get an idea of whether the system is under attack. There are systems, actually the box that we have down there, you can put it at the entrance of your network, and it will analyze all the traffic, and it will give you a much better analysis and detection, because it's based on data. The idea here is to do the initial analysis based only on counters, and when there's suspicion, then you go and do further analysis. The advantages of this is that these devices are usually expensive, and if you want to be able to analyze all your data in real time, you're essentially wasting resources. It's better just to analyze the suspicious data and not everything. So that's the idea. And to do all of that through the controller in the application, the controller are not designed to get all the data. This whole packaging thing is supposed to be used every once in a while and not all the time, because otherwise you cannot do through the controller in the application inline data analysis. It will break the system. Does that answer your question?
How much time does it take for you to build that model?
To build the model, Gera, how much time does it take us to build the baseline?
It depends. It varies between minutes to days, depending on the behavior of the system, the variance, and also it depends on how accurate you want to be.
Basically, if we have a longer time to learn, the accuracy, the false positives that we will have are smaller. If we just learn very little time, then we really don't know what's the behavior. Okay? So now we have an attack detected. As you can see, the traffic some of it is good, some of it is bad. At this point, our application determines that it needs further analysis, and now it's not only statistics-based, but we want to actually look at the data. But we want to look only at the suspicious data. So through SDN mechanisms, we are able to, first, this is one of the things that I told you, there is some optimizations. We can take the baselines that we have built over time, since the scrubbing center has not seen any data, it will take longer to detect the attack if it had no baselines. So we could actually push the baselines into the device. It will work without it. It will work better with it. This is where we actually have done it for our device, but anybody, it's open source, anybody can do it to other devices. Then we instruct the controller to redirect the suspicious traffic. This means that some of the traffic is still going directly. It's tricky here. You can fall down. And only the suspicious traffic is going down into the scrubbing center. This is a very important improvement over similar systems, not SDN-based, that even if they do statistics-based detection, when they decide to redirect, they redirect everything because they do not have the granularity to only redirect specific, the suspicious traffic. The suspicious traffic gets to the scrubbing center. In the scrubbing center, we do further analysis, and what comes out of this machine is essentially clean traffic. We can put the clean traffic back into the network so it reaches the destination. The bad traffic is thrown away. This is basically the way the system works. So what do we need to make this system work? We look at OpenDaylight and we say, well, great, there's an open source controller where we can actually not only build on top of the controller, but we can actually put inside the controller the functionalities when we need. And there is a very clear distinction between what it is application level logic and what it is more of a network level logic that we need. So our initial design, when we thought about coming into OpenDaylight, was, well, we're going to divide our system into what is the security logic, the analysis logic, the redirection logic, from the actual network componentry. So we have, as you see, an application that is sitting on top of the REST API. And to support this application, we needed two different types of services in the controller. We needed what we call the statistics service, and we needed a redirection service. What are these services doing? Basically, the statistics service is enabling us at a very high level to define counters. So I want to say, count this particular type of traffic. Please count all the TCP packets that are going to this subnet. Count all the UDP packets that are coming into the network. So I want to define a traffic selector and let the system at the bottom put the counters wherever it makes sense to be able to catch all the traffic that matches this condition. If we take a look at this example, we can have a network where I have traffic coming from two different directions. And I want to put counters that count the data that is going to one specific machine at the bottom. So without this statistics service, it will mean that my application will have to go and understand the topology and put counters wherever is needed to reach that particular destination. It may mean more than one place. So instead of having that at the application level and mixing our application with some topology stuff, we had this distinction. This is a network service. So we want a service that actually enables us to define a high-level counter, and the service is the one that is going to go and put it in the right places. For example, for this API call where I say the Defense4All says, add a counter that is counting the TCP traffic for the destination X. This translates into putting flow entries in different places in the network. For example, it may mean that I want to count, that I may want to count at the very bottom, at all the entry points to the network, I will have a flow entry that is counting for me. And then when I read the counter, that means that the service will actually have to go into each of these flow entries and get the partial summaries, partial results from each of them and aggregate. Or in some other deployments, it actually may mean that I can take this counter and put it the closest possible to the destination. It's a different place to put it.
Some reflections on the communication between functional blocks
southbound interface? Is it really OpenFlow specific? I mean, we've been using BGP to do this kind of stuff for 10 years. Can you use BGP from the controller or BCP or any other southbound protocol to program your network?
No, the northbound interface, the way that we specify what we need to the controller is not OpenFlow specific. It does has this traffic selector thing, does has kind of an OpenFlow like matching expressions, but it's just because it's a language to express what we want to match against. It's not really depending on OpenFlow. Underneath, you can go down and do it any other way. Actually, you don't really do BGP to do the counting. You do BGP to do the redirection.
You reset next hop. You reset next hop to shunt the traffic through.
To do the redirection, yes, the next slide, you do BGP. There are other mechanisms of doing it, but at the top, we're not really using OpenFlow. We're using a higher interface. That is what the statistics service API was supposed to do. And I'll explain later on why it's not doing it, because that's part of the integration with the project. Okay, another interesting functionality that this statistics service needs to provide to me, let's assume that that machine is a virtual machine and is moving around. At the application level, I do not want to have to track the machine and all the time move flows from one switch to another. It's up to this statistics service to do that. That's one of the things that we needed, the division between security-related code and networking topology-related code. The other service that we needed in the same line of thought of putting networking stuff underneath and separating it from the security stuff is the redirection service. Yes, this could be done with BGP. We do it with in OpenFlow it's done with in OpenDaylight is done with OpenFlow, but yes, it could be implemented through a BGP plugin under South. Why we need the redirection service? What kind of issues we have with redirection? Let's say that I say now I do not want to count the TCP traffic. I want to move the TCP traffic for X to a scrubbing center. Now, if I were to do that at the application, I have to understand all the possible paths from the entrance to the network to my protected object and make sure that all the switches along the way have the proper redirection flow entries. That may be not that bad, but it may be a lot of hard work. And again, it needs to follow wherever the machine is moving. Not only do I need to put the flows that bring the traffic into the scrubbing center, I also need to put flows that take the good traffic back into the original path to make sure that they reach the destination through the normal routing. So this is kind of things that are not specific to our application. We need it because we need to do redirection, but we need this separation. So that brings us to this design. We have our main logic at the top. Is doing REST to create counters. Is doing REST APIs to move traffic. And it is up to these two boxes to do the networking stuff. Now, when we presented this to our OpenDaylight colleagues, they said, this is all very nice, but you know, why are you doing this network-related stuff? Your expertise is security. We have guys that know how to do path combinations in a better way, and we have guys that know how to do host tracking better. Why are you redoing that work? It is better to actually look at what's available at the controller and try to reuse it. So basically, there are two components existing in OpenDaylight that with some changes to the way we were thinking of doing things, we can actually use this stuff instead of developing our own. One is the statistics manager, and one is the affinity service. So instead of coming up with these 3 boxes and developing them ourselves, which means a lot of work, and in some cases, work in areas of expertise that where we do not have the expertise. Instead of doing that, we were able, or to at least in the design, because this is not implemented, and that's another issue, and I'll explain that. But in the design, we say, okay, we remove these networking services from the diagram, and instead of that, we're going to build our application on existing services. What does this mean? No, this is just an animation of what I just said. This is basically the way we envision the system. We have the Defense4All here on the left, and we have, for example, the traffic redirection system. So whenever the Defense4All notices that the system is, that one of the protected objects is under attack, it will issue a very simple API that says, take the suspicious traffic, move it to a scrubbing center. It's a simple API. What it means to do this is not the Defense4All problem, it's the traffic redirection problem. Same when we identify that the attack has finished, we just invoke the stop redirection API, and magically the network is reconfigured to work as normal. This was the way we initially designed the system. Then we talked with the OpenDaylight guys, we talked with the Affinity guys, and we understood that with some minor changes to our flow, we can essentially achieve the same functionality, reusing components, and in a sense, in a better way, because we're using a more abstracted model of the network. So basically, this is what happens. It does look much more complicated than the previous one, but in fact, it's not. First, we have a long initialization process where we're building these affinity groups and the relations between the affinity groups. But this is something that we do once. What we're doing here is we build something that is called the suspicious traffic group, and we leave it empty. We will build another group that is called the mitigation group or the scrubbing center group. In there, we put the address or addresses of all our mitigation devices. We also create in this initialization step a link between these 2 groups, and as one of the attributes of the link, we say that this is a path redirect link or relation. What this means is that whatever falls into the first group will be redirected into the second group. How does that happen? It's magic. But that's exactly what we were looking. We were looking for that magic to hide away the complexities of the network and the topologies and the movement of the virtual machines and give us a high-level API. So after all, we have all of this complex in it. We now have a very simple construct that we use during attacks. So when there is an attack, we also have a single API, just as we had before. But instead of doing redirect traffic, what we now do is we say, add to the suspicious traffic group the traffic selector. So now the affinity service will be responsible for selecting the traffic and making sure it goes to whatever is in the mitigators group. Similarly, to stop the attack, we just remove error in the animation. We remove the attack traffic selector, not the addresses. I removed the wrong component in my PowerPoint. Yes?
Capacity of scrubbing device as well as link to the scrubbing device is limited. Do you track amount of traffic going? Can you redirect to another group when the link is full? Can you preempt by another group?
Well, currently we don't do that. We assume that the link, we're redirecting only partial traffic. We're not moving everything. So we assume that we have the same capacity coming into the network and going into the scrubbing center, and anyways, we're going to push in that direction less traffic. But yes, we could do some kind of optimization on this and distribute the traffic over different scrubbing centers to remove the load on the link.
Any plans?
Hmm?
Any plans?
We have planned to do that. To have the traffic, not all the traffic sent to a single scrubbing device, but to several scrubbing devices that are connected through different links. Okay, so actually have much more time than what I thought I will have. So the presentation, I always think that I'm going to run out of time, and it looks like I'm going to finish before time. The idea of coming into this open source essentially help us develop faster because we can reuse components and we can actually leverage the expertise of others in areas that we do not have expertise. This is essentially the main message that the summit organizers wanted me to give you. It was very good for us to work here because in theory, it saves us a lot of work. In practice, I have to be honest, we did not implement this using the Affinity service. We did not implement it with our additional service. We just implemented through a very simple topology. In this release, we support a single switch topology, and we do flow programming directly. Lack of time, but now, instead of needing to support a more complex topology, our plan is to switch to an abstraction, whether it's the Affinity or what is going to replace Affinity in the future release, because there are already talks about a new project that is going to include the functionality of the Affinity. This application policy grouping, I think it's called, is going to replace the Affinity. But if we build our APIs, the switch from direct flow programming to using this high-level API is relatively small because we do not need to reprogram the whole network and understand topologies. To actually move from a single switch flow programming to a full complex network direct programming is a big step for us, and through this collaborative model, we do not need to do it. Now, another very interesting thing of our experience in this project is not only that we got what we wanted, but being an open source project, if we really need something and nobody can do it, we can always put it there. With other controllers and our application, we actually have a commercial version of this application that has some more advanced detection mechanisms. But essentially, on our commercial application, when we go to a closed source controller, all we can do is put our requirements to the controller company and hope for the best and build a joint business model such that it is worthwhile for them to develop it. In here, if we don't have it, we can always put the resources ourselves and make sure it goes in there. And that's a great advantage. We do not need to wait. And we're currently in different stages with different controllers where some of the functionality they're putting it, some is delayed to other releases. And in the meantime, there's not much we can do to influence the direction. In here, it's totally different because it's open. You can always put it yourself. So any questions to working with OpenDaylight or about our application?
Scrubbing device, does it have to be physical device or can it be virtualized?
No, it doesn't have to be a physical device. It can be a virtual device. It can actually be a scrubbing service system. There are some companies that actually provide you scrubbing services. So you can actually redirect the traffic to Prolexic, I forgot the name. There are companies that actually provide a scrubbing center as a service. So you do not need to have a physical device. You can have virtual machines that do it. You can have a company that is doing it as a service. In fact, in our roadmap, we have plans to have a virtualized version of our scrubbing device. We still do not have it working, but it's going to be available soon. Currently, we only sell the boxes.
Do you envision integration of OpenStack,
Hmm?
OpenStack model in ODL, so it can span new VM running the service on demand?
Yes. Yes, we actually, as I say, we are planning on having the box. Where is the box at the bottom virtualized, and as part of that process, we clearly are going to integrate the on-demand provisioning of these boxes through OpenStack. We have done that. We have two lines of products in Radware. One is security, the attack detection and mitigation that you see here. We also have an ADC. Our ADC is already virtualized and fully integrated with OpenStack. In fact, as far as I know, is the only commercial implementation of the LBAS OpenStack API. So our plan is to do the same. Virtualize and then push, just as we push LBAS, push some anti-DOS standardized API into OpenStack and follow the same model that we already did with our ADC product. There was a question back there.
So, when you're doing any of these policy group things, whether it be affinity or the application policy, I can have a lot of groups for a lot of reasons. If you're doing a separate group for suspicious traffic, do you need to double the number of groups that you had before?
Do I need what?
You need to double the number of groups that you had for other reasons.
In our case, if I understand correctly their question, not really, because in this setup, in the virtualized setup, it's going to be different. But in this setup, I have a scrubbing center that is serving all of my customers. So once I have this group of traffic suspicion and the link that says whatever is in that group, move it to the scrubbing center, I can put into that group all the traffic filters that look suspicious. I do not need more groups.
Okay, the reason I'm talking about doubling is not because of what you're doing, but there may be other things people are doing for other purposes, different services, different policies that have nothing to do with what you're trying to do.
Mm-hmm.
You still need to apply those as well as direct some traffic to your scrubbing center and have other traffic not go to your scrubbing center. So doesn't that mean you need to double the number of groups?
Well, I think the whole problem of having several applications running on the controller and doing different stuff is a very big problem that up to now I haven't seen solved. It's not specific to the application policies. It's a problem inherent in this model. Up to now, most of the applications out there are a single application on a single controller. But that's an issue that any controller to be successful needs to solve it, whether it will be through the application policies and some prioritization on them or some other mechanism, I don't know, but that's one I believe is one of the most biggest problems with this whole SDN that nobody has really given an answer of the several applications doing different things together.
So we were discussing things this morning with related to policy of having some sort of label so that you wouldn't need an entirely different group, but within this group you could have some actions that are dependent on having a certain label or not. So you can label them suspicious. So it's related to all the policy and grouping things, but might not be the top level group.
Yeah, but that I believe is just a matter of semantics, where you have one group with labels that essentially you are subgrouping within the group, or you have different groups.
No, but from a policy point of view, I think it'll make it easier.
Yeah, but I mean, essentially, you can have groups and subgroups within the group, or many groups.
From a very high level, yes, it's still groups.
Yeah.
Yeah, but the reason the label would be nice is you can construct a service chain with a conditional element in the chain that if it's a member, if it has this label, then you go through this additional service in between these other services. And then it should just fall out.
Yeah. As again, I presented here what we planned. We didn't end up doing it, but what we planned to do on top of Affinity. Affinity doesn't have labels. Now that something is going to replace affinity, we're probably gonna align ourselves with whatever mechanisms that this new application policy is gonna give us. So if one big group and labeling makes sense, we're gonna do it that way.
Yeah, within the application policy, we talked about redirect. I don't believe there's any service chaining model as of yet, but it should become the same.
Yeah, I think service chaining is a very important thing. Redirect to a single point as we have here is just a special case of a service chain. You can think of this being a service chain because things go to the scrubbing and then go to the destination. So you created a chain, kind of. It's a special case. You need to solve the more general case. Actually, in the proposal that we put for a similar API to the ONF, we don't talk about redirecting to a device. We're talking there to create a chain. But that may also change as following this policy discussion, which in my view makes a lot of sense.
Yes, so what version of OpenFlow are you using, and are you looking at, say, using some of the features of 1.1, 1.3, etc.?
Well, as I mentioned earlier, from the high level, this is not specific to OpenFlow.
Okay.
What we need, the language that you're using to specify the traffic looks like OpenFlow, but underneath it can be anything. Specifically to the release one that just came out yesterday, and we're doing direct flow programming, we're doing 1.0. For this particular application, I don't see anything that 1.3 will add. Actually, 1.4 has some very interesting things from our point of view because we could do matching on the TCP flags, which is not available up to 1.4, and that means for security application is a big advantage. So whenever that's out, we're going to probably want to use it. 1.1, 2, and 3, for this particular application, I don't see any value. For other applications that we have, we actually require 1.3. But for this particular one, correct me if I'm wrong, Gera, there's nothing specific that the 1.3 help us. Any other questions? The what? Detail in what sense?
Just give an elementary view, like how do you come up with the detection scheme?
Gera?
Again, what's the question?
Come here so they can hear you. They want a little bit to understand the detection mechanism on what we actually do in the application itself.
The detection mechanism is pure rate-based. That's the open source version. In commercial version, we have other means for better, more accurate detection. But for open source, it's rate-based in the sense that we learn normal traffic behavior, normal rates, and we constantly update those rates as time goes by. But when we detect significant deviation, when we detect a significant prolonged deviation from the normal rates, we declare an attack. Okay, and then once we move traffic, as Benny said, to scrubbing centers, and we get additional feedback from those mitigating devices, we integrate that feedback along with the traffic rates we get from SDN. Does that answer your question? Somewhat.
The rate is not It's not just simple counting packets, because there are the relations between the types of traffics are also important. Yeah. So to avoid false positives. Also, with the open source version, we will have more false positives that you will have with the commercial version, and even in the commercial version, you will still have false positives, because the only way to make 100% sure is by actually analyzing the data. But it does save a lot of traffic going in through the scrubbing devices, which means that you can have a smaller capacity device, or if you're a cloud provider, you can use the same device to many customers, because you're only moving their suspicious traffic.
Basically using machine learning mostly in the commercial version.
Any other questions?
What happens when you have a multi-controller topology? How do you handle this? Like, where is the graph abstraction? Do you operate on the graph? Your application operates on the graph.
Well, currently we do not support the multiple controller version. It's supposed to be part of this abstraction that we shouldn't really be dealing with topologies or which controller controls which switches. The nicest model will give us something that not that we're there. What we would like is we talk to this one thing that deals with all that thing. Our application is built for clustering capabilities within the application. High availability and scalability, we have it within the application, but that's independent of the clustering of the controller. Any other question? No? Thanks a lot. I can give you back 6 minutes. And we do this purely using SDN-based elements, both for the detection and for the diversion. So basically, how does this work? What we see here is all the components of the application. We have our SDN controller, obviously OpenDaylight. On top of that, we have our anti-DOS application. This application communicates it's not integrated in the controller itself. It communicates with the controller through the controller REST APIs, to the northbound API of the controller. Clearly, we have our user interface, and at the bottom, we see our network. Our network is made out of physical machines, it's made out of virtual machines, and we have something called a scrubbing center. That is the place where the attack traffic is cleaned up. Now, to do this is done on hardware devices. It can be our device, or it can be somebody else's device. The application itself knows how to divert the traffic to the scrubbing center, and the scrubbing center does not necessarily have to be based on our devices, because all the application is doing is moving the traffic there. There are some optimizations that we do, and I'll show you what it means, but essentially it will work with any anti-DOS device here. So how does the system work? We have this concept of protected object. The user, through the UI of the system, defines a set of machines or a machine or a link that it wants protected. So as you can see here, out of many machines, I have set up protection for this particular physical machine, and I have also set protection for this set of virtual machines. Now, what this means is that our system is works with whatever the components that we're trying to defend. We're not really, or should not be, dependent on whether this is virtual, this is physical, on what virtual technology you're using. This is all theory, but this is the main idea. Once we have defined our protected objects, the user gets out of the picture, and the system takes the definition of protected objects and translate that into counters. We essentially go to several places in the network, and we put specialized counters that count different types of traffic. This is not just counting bulk packets, but we do have counters for that count TCP traffic, and we have counters that count ICMP, and we have traffic counters that count UDP, and the detection is actually based on the relations between all these different traffics and the behavior of this traffic, of these different types of traffic over time, and of the location, because it's different if we're having a counter at the entrance of the network, or we're having it at the very edge of the network. We expect different behaviors. So what we do in the applications is we take the results of these counters. Once we have the counters, we periodically poll. This is a polling system. This is, as I mentioned, is a REST API. So we need to poll to collect the information through the controller from the different counters. Then we actually put together all the different counters, and we learn for any specific protected object what is the normal behavior, because different machines have different normal behaviors. So it's not like you can say, well, this particular traffic pattern means that you're under attack, because for some it may be okay, for some others it may not. So essentially, we collect over time, we learn what is the normal traffic of a particular protected object, and then we look for anomalies. We look for anomalies that mean that based solely on counters, we do not analyze the data. It's based solely on counters, on insights that we have on the behavior of traffic, and what does these counters mean, that we actually say that we have suspicious traffic. It may not be an attack, it's suspicious. Yes, you had a question?
Why not inspect the flow data right there?
What?
I said, why not inspect the flow data right there instead of just counting the high-level stats?
Because if we were to move all the traffic through the controller to our application to actually do the analysis, neither the controller nor the application will be able to. The idea here is to just, with very little information, get an idea of whether the system is under attack. There are systems, actually the box that we have down there, you can put it at the entrance of your network, and it will analyze all the traffic, and it will give you a much better analysis and detection, because it's based on data. The idea here is to do the Rochwerger from Radware. Radware is a company based out of Israel. We specialize on application delivery control and security. And I'm here going to talk about the experiences that we had developing this anti-DOS application on top of OpenDaylight, and the trade-offs that we made, and how the environment was very friendly for us to develop in. So before I go into actually the integration on OpenDaylight, let me explain you a little bit about what our application does. Essentially, the Defense4All is the open source version of our SDN-based anti-DOS. Essentially, it's a system that detects DDoS attacks and has the mechanisms to take traffic that is an attack traffic and move it somewhere else to be cleaned up. So the target of that attack never feels that it's under attack.